All right, in this lesson, we're going to solve equations with complex numbers. All right, so the actual lesson itself, you're going to see, this is going to be kind of a short video. Just because we've done these examples before, it's just now we're including negatives underneath the radical, which from the previous lesson, we should now know is I, right? So instead of getting no solution in this case, we would get answers with I in them. All right, so we'll start with this first one. So something like x minus 2 squared equals negative 20. All right, I see something squared, so I can get rid of that square. Right, I taught you guys to square root both sides. And then that square root and the square are going to cancel out. And so you end up with an x minus 2 equals plus minus the square root of negative 20. And then I can solve for x as normal, right? Add 2 on both sides. And we get x equals 2 plus minus the square root of negative 20. All right, so then from here, you just want to simplify that radical as much as you can. All right, so the square root of negative 20, that negative underneath the radical is going to become an I. And the square root of 20 becomes the square root of 4 square root of 5. All right, and the square root of 4 is 2. So then writing our final answer, this would get us x equals 2 plus or minus, and then this radical simplifies as 2I squared root of 5, just like you learned in the previous lesson. So that's really the only thing that's new about this lesson, but really the math itself is stuff that we've done before. All right, so I'll try the exact same thing with the next one. All right, so 3x minus 1 squared, I see a square. I can get rid of that square by square rooting. And so I get a 3x minus 1 equals plus minus the square root of negative 48. And then we can get that x by itself by adding 1 to both sides. So we get a 3x equals 1 plus minus the square root of negative 48. And then you can divide by 3. And then 3's cancel out. And so we get x equals 1 plus minus the square root of negative 48 over 3, right? So that part's normal, right? Nothing new. The only difference here is that now I have a negative under the radical, which I can replace with I. And the square root of 48 I can write as the square root of 16 square root of 3, right? Or you can use a factor tree, right? Whatever works best for you. So then we get 1 plus minus, the square root of 16 is 4. And then there's an I, and then there's just a radical that can't be simplified. So we get 1 plus minus 4I square root of 3 over 3. Right, so really just simplify the radical as normal. But again, every single example in this lesson is going to have I. Right? So when you look at something like this, x squared plus x plus 5, right, it's not going to be like the first two. This one's in standard form. Now, an equation in standard form, I can use the quadratic formula for. All right, so I can use a equals 1, b equals 1, and c equals 1. And then just plug these numbers into your quadratic formula. So x equals negative 1. So negative b plus minus the square root of b squared. So 1 squared minus 4ac. So 4 times 1 times, sorry, this should be a 5. All right. Over 2a, so over 2 times 1. And so we get a negative 1 plus minus the square root of 1 minus 20 over 2 equals negative 1 plus minus the square root of negative 19 over 2. All right, so this becomes our answer. Just the only thing is that now I have a negative under the radical, which becomes I. And the square root of 19, I can't simplify anymore, so that just stays I square root of 19. So we get x equals negative 1 plus minus the square root, I square root of 19, right, over 2. And that's our final answer. All right. This next one we can do the exact same thing with. Right, it looks like a quadratic equation in standard form, so I'm going to label a equals 1, b equals 3, and c equals 10. So I'm going to get x equals negative b, so negative 3 plus minus the square root of b squared, 3 squared minus 4ac, 4 times 1 times 10, over 2a, so over 2 times 1. All right, and that's going to get us a negative 3 plus minus the square root of 9 minus 40 over 2 equals negative 3 plus minus, all right, 9 minus 40 is negative 31. So square root of negative 31 over 2. And then the square root of 31 can't simplify anymore except for that negative, right? That's going to become an I. So we get an I square root of 31. So we get x equals negative 3 plus minus I square root of 31 over 2. All right, so hopefully nothing too crazy there. All right, same exact process in this page, right? Just solving a normal quadratic equation, just you might get I in your answer. right? So here I have an x squared and a 25. I can move 25 to both sides. And so we get x squared equals negative 25. Square root both sides, I get x equals plus minus. That negative is going to become an I. All right, but the square root of 25 is 5, and that's a whole number. So I'm actually going to write 5i. All right, so I always want the I after the number. The only case where we would write it before is if there's a radical. Like I said in the previous lesson, right? We don't want to make a mistake and extend that radical to include the I in it, right? So I want them to be separate. So we get this as our answer. All right. This next one we can do just like we did in the previous slide and use the quadratic formula. This is actually one where it looks like completing the square might be a little bit better. All right, just because A is 1 and B is even. All right, so let's actually complete the square for this one. I'm going to subtract 9 on both sides. We get an x squared plus 2x plus a blank equals negative 9 plus a blank. And then in that little blank is going to go b over 2 squared. So 2 over 2 squared, which is 1 squared, so 1. All right, and then so this left side is going to become our perfect square trinomial. So x plus 1 squared equals negative 9 plus 1 is negative 8. All right, and then I can square root both sides. Get x plus 1 equals plus minus the square root of negative 8. Subtract 1 on both sides, and I get x equals negative 1 plus minus the square root of negative 8. All right, and then this, you just want to simplify as much as you can, right? So that negative is going to become an I, and the square root of 8 becomes the square root of 4, the square root of 2. And the square root of 4 is 2. So then I get as my answer x equals 1 plus minus 2i square root of 2. If you did the quadratic formula, you should have got the same answer, right? You just need to make sure you're simplifying fully. All right, so we get this as our final answer. All right, so for this next one, we can do the same thing, right? I'm going to subtract 9 on both sides. 25x squared equals negative 9. All right, and then it looks like I can solve by square rooting, right? So I'm going to divide by 25, get that x squared by itself. And so I get x squared equals negative 9 over 25. Square root both sides, and so I get x equals plus minus. I can square root the top, square root the bottom, right? You're always allowed to do that with square roots. All right, and the square root of 9, or negative 9, is going to get you 3i. So I get plus minus 3i over the square root of 25 is 5. All right, so we get that as our final answer. All right, now with this last one, right, it looks like there's a square, so I can solve by square rooting. I'm going to divide by 3, and so I get an x minus 1 squared equals negative 16 over 3. And then once again, I see that square, I can square root both sides. So I get x minus 1 equals plus minus. Just like before, I can square root the top, square root the bottom. All right, so then I can add 1 on both sides, and I get x equals 1 plus minus. The square root of 16 is 4i, or negative 16, sorry, over the square root of 3. All right, and then I have a square root on the bottom. We can get rid of that by rationalizing, right? So you never want to leave a square root on the bottom. So you get x equals 1 plus minus 4i square root of 3 over 3 as our final answer. You can leave it like that. There's a way to get it under a single fraction, but honestly, this is perfectly fine as an answer. All right, and that's the whole lesson, right? Didn't take super long. I was going kind of fast for some of them just because, I mean, the actual content part of it we've learned before, right? The only new thing is that now you have I showing up in your answer, right? And now that we know I exists, right, you can consider it fair game for any equation that you're going to get in the future, right? So it's not that this is our lesson now and it's never going to show up again, right? It's similar to factoring, right? Once I told you guys that you needed to factor, you're noticing that recently we've been needing to factor a lot. And in the next lesson, we're also going to need to factor a lot. All right, so that's I is another thing that's never, ever, ever going away. All right, so next lesson, again, might include I as well. But that's it for this lesson, right? So it shouldn't be super crazy.